This is lesson 9.5 about geometric series. In this lesson, we will continue working with geometric series, but in particular, we're going to work with infinite geometric series. So this was our formula to find the sum of a geometric series, but it wasn't just any geometric series, it's only a finite geometric series. So if you have a finite geometric series, you can find its sum using this formula. Then we had this example, and in this example, this is a finite geometric series because we had a first term of 3 and a last term of 3072. The question is, can we add a series that doesn't have a last term? What if it ends with an ellipses? And the answer is sometimes you can find the sum of that series. We will derive the formula in class, but for now, what you need to know is that this is the formula for finding the sum of an infinite geometric series. What you also need to know is that the series will only have a finite sum. In other words, the sum is not infinity, if the series converges. The series will converge if our common ratio is less than 1. And it's actually the absolute value is less than 1. But we could have an infinite geometric series that does not converge if the R value, the common ratio, is greater than 1, then it does not converge, and if it does not converge, then you will not have a finite sum. The sum would just be infinity. So let's get some examples. Example A here. This is an infinite series because it does not have a last term. It has the ellipses. So then we have to decide if it converges or not. If it does not converge, then it diverges. So to determine if it converges, we calculate the common ratio. So common ratio is the second term divided by the first term, which should be the third term divided by the second term. And in this case, R is 0.5. Since 0.5 is less than 1, this series will converge. Since we know the series converges, then we can find the sum of that series by using our formula. So the sum of the series will be the first term divided by 1 minus the common ratio, which was 0.5. So if we put 0.5 as a fraction, maybe this would be easier. 1 minus a half is a half. And when dealing with fractions, 1 divided by a half is the same thing as 1 times the reciprocal to a half, which is 2. So the sum of this series is 2. Okay, in example B, using summation notation, we can also see that this is an infinite series because above the summation sign we have an infinity symbol. And to determine if it converges, we have to look for our R value. In our formula, this first term is A sub 1, and the second term is R. Since R, 5/4, is greater than 1, the absolute value of R is greater than 1, this series does not converge. In other words, it diverges. Since it diverges, it does not have a finite sum.